Tonight, we journey to the coldest places in space. Let your breathing slow. Let your thoughts grow quiet. Allow the weight of your body to settle into stillness as we prepare to drift together through the vast and silent reaches of the cosmos. There is no hurry here. There is no urgency. Only the gentle unfolding of time, stretching across billions of years, carrying us softly into the deepest darkness the universe has to offer. In the spaces between stars, far from the warmth of any sun, there exist places of profound and ancient cold. Places where temperatures fall so low that the very concept of warmth becomes a distant memory. Places where matter itself seems to pause, to rest, to wait in eternal stillness. These are the realms we will explore tonight, not with haste, but with the quiet patience of starlight crossing the void. We will drift through cosmic clouds where new stars are slowly being born. We will visit moons wrapped in perpetual twilight. We will travel to the edges of our solar system, where the sun appears as nothing more than a bright star among millions. And we will venture further still, to places where the cold reaches depths almost beyond comprehension. But there is nothing to fear in this darkness. There is only peace, only stillness, only the gentle, endless quiet of the universe holding its breath. The cosmos has been here for nearly 14 billion years. It has watched countless stars ignite and fade. It has witnessed the birth of galaxies and the slow dance of matter across unimaginable distances. And through all of this, in the spaces between the light, the cold has remained. Patient, quiet, eternal. So let us begin. Let us drift together into the cold and the dark, where time moves slowly and the cosmos whispers its oldest secrets to those patient enough to listen. Close your eyes if you wish, or let them rest half-lidded on the gentle darkness around you. Either way, you are safe. Either way, you are held. The universe is vast beyond imagining, but it is not indifferent. It created you, after all. It gave rise to the warmth and light that sustains you. And tonight, it invites you to explore its quieter realms, its darker corners, its places of deep and ancient cold. Let us begin our journey. To understand the coldest places in space, we must first understand what cold truly means in the language of the cosmos. Here on Earth, we think of cold as the absence of warmth. A winter night, a frozen pond, the chill of early morning before the sun has risen. We wrap ourselves in blankets and coats, seeking to preserve the heat that our bodies generate. We build fires and turn on heaters, pushing back against the cold that would otherwise creep into our homes. But in the vast reaches of space, cold takes on a meaning far more profound. Cold, in the cosmic sense, is the natural state of the universe. Warmth is the exception. Warmth is the rare gift of stars, those brilliant furnaces scattered like distant campfires across an infinite dark plain. Imagine, for a moment, that you are drifting through empty space, far from any star. There is no air here to carry sound. There is no wind to touch your face. There is only the silent vacuum and the gentle glow of countless galaxies wheeling slowly in the distance. In this emptiness, the temperature falls to approximately 270 degrees below zero on the Celsius scale. This is what scientists call the cosmic microwave background temperature, the faint warmth left over from the earliest moments of the universe, when all of existence was compressed into a space smaller than a single atom. 270 degrees below zero. It seems impossibly cold, and yet this is merely the baseline. This is the background hum of the universe, the gentle whisper of ancient light that has been traveling through space for nearly 14 billion years. In certain places, in the shadows of cosmic clouds, in the darkness between galaxies, the temperature falls even lower still. But let us not rush ahead. Let us rest here for a moment, in the contemplation of this cosmic chill. The universe, you see, began in unimaginable heat. In the first fraction of a second after the great expansion that brought all things into being, temperatures were so high that they cannot be expressed in any meaningful way. Trillions upon trillions of degrees. A heat so intense that matter itself could not yet exist. Only energy, pure and formless, expanding outward in all directions. Picture, if you will, that first moment. Not an explosion in space, but an explosion of space itself. Every point in the universe suddenly rushing away from every other point. Energy filling every corner of existence, so hot and so dense that light could not travel through it. The cosmos was opaque, a fog of brilliance that would not clear for hundreds of thousands of years. But the universe is patient. The universe has time. And slowly, over millions and then billions of years, the cosmos cooled. The great fire dimmed. Matter condensed from the cooling energy like dew forming on morning grass. Atoms came together. Clouds of hydrogen drifted through the expanding void. And in the heart of those clouds, gravity began its slow, patient work. Stars were born. These first stars were giants, hundreds of times more massive than our own sun. They burned hot and bright, illuminating the darkness for the first time. The universe, which had been opaque and then dark, finally began to fill with points of light, islands of warmth in an ocean of cold. But they were scattered, those ancient fires, few and far between in a universe that was already vast beyond comprehension. And between them, in the spaces where their light could not reach, the cold remained. It remains still. When you look up at the night sky, you see the stars. Bright points of light, seemingly crowded together in the tapestry of the Milky Way. But this is an illusion created by distance. In truth, the stars are separated by almost unimaginable gulfs of empty space. Our nearest stellar neighbor, a small red star called Proxima Centauri, lies more than 4 light-years away. This means that light itself, traveling at 300,000 kilometers every single second, takes more than 4 years to cross the distance between us. And in all that space, in all those trillions upon trillions of kilometers, there is almost nothing. A few atoms of hydrogen per cubic meter, the occasional grain of cosmic dust, smaller than a mote in a sunbeam, and cold. Endless, patient, eternal cold. This is the true nature of the universe. Not the blazing hearts of stars, magnificent though they are. Not the warm, blue-green sphere of our own planet, precious though it is. The true nature of the universe is darkness and cold and silence. The warmth we know, the light we see, these are small islands in an ocean of night. Rare oases of energy in a desert of stillness. And there is something strangely comforting in this thought. The cold of space is not hostile. It does not rage or threaten. It simply is. It waits, patient and eternal, as it has waited since the beginning of time. It will wait still when all the stars have burned themselves out, billions upon billions of years from now. The cold endures. The cold persists. The cold is the universe at rest. Let us drift now through this cosmic baseline, this gentle chill that permeates all of existence. Feel the silence of it. Feel the stillness. In the vacuum of space there is no sound, for sound requires air to carry it, and here there is no air. There is only the soft glow of distant light, the ancient whisper of radiation left over from the birth of all things. In laboratories here on Earth, scientists have learned to create temperatures even colder than the cosmic background. Using lasers and magnetic fields, they can slow atoms to a near standstill, reaching temperatures just a fraction of a degree above absolute zero, that theoretical point where all motion ceases entirely. But the universe achieved this cold naturally, in certain special places, long before any scientist was born. These are the places we will visit tonight. The shadows between stars, where temperatures fall below even the cosmic background. The dark nebulae where light cannot penetrate.
the frozen moons at the edges of distant solar systems, the voids between galaxies where nothing has stirred for billions of years. But first, let us understand absolute zero. This is the coldest temperature that can possibly exist, at least according to our current understanding of physics. It sits at -273.15 degrees Celsius, a number that scientists often express as 0 Kelvin, using a scale that begins at this ultimate cold. At absolute zero, the atoms that make up all matter would cease their eternal dance. They would stop vibrating, stop spinning, stop moving entirely. In practice, absolute zero can never quite be reached. There is always some tiny residual motion, some quantum whisper of energy that refuses to be stilled. But the universe comes very, very close. In the Boomerang Nebula, a cloud of gas and dust located 5,000 light-years from Earth, temperatures have been measured at just 1 degree above absolute zero. This makes it the coldest natural place we have ever discovered. Colder than the space between galaxies, colder than the shadow of the most distant planet, colder than almost anywhere else in the entire cosmos. We will visit the Boomerang Nebula later in our journey. For now, let this thought settle gently into your mind. Somewhere out there, in the darkness between the stars, there exists a place where cold has reached nearly its ultimate depth. A place where matter barely moves, a place of profound and perfect stillness. And even now, as you rest here in your own warmth, that cold place drifts silently through space. It has been there for thousands of years. It will remain there for thousands more. Patient, quiet, eternal. The cosmos keeps many secrets in its cold places. In the shadows where light does not reach, matter takes on strange forms. Ice crystals grow in patterns never seen on Earth. Molecules that would instantly evaporate in warmer conditions remain frozen solid for billions of years. The cold preserves, the cold protects. The cold holds things in a state of perfect, unchanging stillness. In the frozen depths of distant moons, there may be oceans locked beneath shells of ancient ice. In the voids between galaxies, there is a darkness so complete that it has never been touched by the light of any star. These are mysteries we are only beginning to understand, secrets that the universe reveals slowly, reluctantly, to those patient enough to look. These are the realms of cosmic cold. These are the places we will explore. And as we drift through them together, remember that there is no hurry. Time moves differently here. 1,000 years pass like a single breath, 1,000,000 years like a gentle sigh. We have all the time in the universe, so let your eyes grow heavy. Let your thoughts grow still. The journey has only just begun, and the cold places of space will wait for us. They have been waiting for billions of years. They will wait a little longer still. As we drift further into the darkness, let us turn our attention to one of the coldest regions in our own solar system. A place that exists at the very edge of the sun's dominion, where light takes hours to arrive, and warmth is nothing more than a distant memory.
We leave now the realm of theory and background and venture into the cold places that exist within our own cosmic neighborhood. Our solar system, for all its familiarity, contains regions of profound and ancient chill, places where the sun appears as little more than a bright star, places where ice has remained frozen since the birth of the planets themselves 4.5 billion years ago. Imagine drifting outward from the Earth, past the moon, that familiar silver companion that has watched over our world since its violent birth. The moon is cold, certainly, at least on its dark side, where temperatures can fall to -170 degrees Celsius. But this is merely the beginning of the cold we will encounter. Past Mars we drift, with its rust-red deserts and towering, silent volcanoes. Mars was once warmer, once wetter. Rivers flowed across its surface billions of years ago. But those days are long gone, and now the red planet sits in frozen silence, its thin atmosphere unable to hold the feeble warmth of the distant sun. Past the asteroid belt we travel, that ring of ancient rubble left over from the solar system's formation. These rocky fragments never coalesced into a planet, held apart by the gravitational influence of mighty Jupiter. Some of them are metal, some are stone, and some are rich with ice, frozen water that has remained unchanged since the earliest days of our cosmic neighborhood. Beyond the asteroids lies Jupiter, the king of planets, a world so vast that all the other planets could fit within it, with room to spare. Jupiter radiates warmth, it is true, more energy than it receives from the distant sun. Deep within its crushing atmosphere, hydrogen gas is squeezed so tightly that it becomes a strange metallic liquid, and this compression generates heat that flows outward into space. But even here, at the outer edge of what we might call the inner solar system, the cold is beginning to deepen. The cloud tops of Jupiter register temperatures of -145 degrees Celsius, and the moons that circle this giant world are colder still. Jupiter's moons are worlds of ice and shadow. Europa, smooth and white, is covered in a shell of frozen water that may hide a liquid ocean beneath. The surface of Europa is crisscrossed with lines and ridges, places where the ice has cracked and shifted, perhaps as tides from Jupiter flex the moon's frozen crust. Beneath that ice, warmed by the gravitational kneading of Jupiter's immense mass, there may be more liquid water than in all the oceans of Earth combined, but the surface remains frozen. Temperatures on Europa hover around -160 degrees Celsius, cold enough to make the ice as hard as granite. Whatever life might exist in the dark ocean below would never know the warmth of sunlight. It would exist in eternal darkness, warmed only by the heat that seeps up from the moon's core. Ganymede, the largest moon in the solar system, is a world of dark and light terrain, ancient and cratered and cold. This moon is larger than the planet Mercury, though far less dense, its bulk made up mostly of ice and rock. Ganymede has its own magnetic field, a faint echo of the magnetic shield that protects our own Earth from the solar wind. But it offers little protection against the cold, which here falls to -170 degrees Celsius. Callisto, pocked with the scars of billions of years of cosmic impacts, drifts in silence at the outer edge of Jupiter's family. This ancient moon has the oldest surface in the solar system, a record of bombardment stretching back to the earliest ages of planetary formation. Every crater, every scar, has been preserved in the frozen stillness. Nothing changes on Callisto. Nothing has changed for billions of years. The temperature on these moons hovers around -150 degrees Celsius and colder, cold enough to freeze the very air we breathe into solid crystals, cold enough to make steel as brittle as glass. And yet, by the standards of the outer solar system, these are almost warm places. The reflected light of Jupiter, the faint but persistent warmth of the distant sun, these provide just enough energy to keep these moons from falling into the deepest cold. Let us drift further outward. Beyond Jupiter lies Saturn, that most beautiful of planets, wrapped in its rings of ice and rock. Saturn is a world of storms and swirling clouds, of ammonia and hydrogen churning in eternal twilight. Its rings catch the faint sunlight and scatter it like a halo of frozen diamonds, billions of particles of ice orbiting in perfect, silent procession. The rings of Saturn are one of the wonders of our solar system. They stretch for hundreds of thousands of kilometers, yet they are astonishingly thin, often no more than 10 meters from top to bottom. Each particle in the rings is a piece of water ice, ranging in size from tiny grains to boulders as large as houses. They orbit Saturn in perfect order, held in place by gravity and the subtle influences of the planet's many moons. The temperature in Saturn's rings varies, but in the shadows where sunlight cannot reach, it falls to -200 degrees Celsius. The ice particles drift through this cold in silence, as they have for hundreds of millions of years. They will continue to drift, slowly losing altitude, slowly spiraling inward toward the planet, until one day the rings will be gone entirely. But that day is far off, millions upon millions of years in the future. For now, the rings remain, beautiful and cold and silent. Saturn's moons are colder still than Jupiter's. Titan, the largest, is wrapped in a thick atmosphere of nitrogen and methane.
This orange haze completely obscures the surface from view, giving Titan the appearance of a smooth, featureless ball. But beneath those clouds lies a world of surprising complexity. On Titan's surface, rivers of liquid hydrocarbons flow through canyons of water ice. Lakes of ethane and methane collect in basins near its poles. Rain falls from the sky, but it is not water rain. It is a rain of liquid methane, falling gently through the thick, cold air to collect in seas that would be familiar in shape, if not in substance. The temperature on Titan is minus 179 degrees Celsius, so cold that water ice becomes as hard as granite, forming the bedrock of this alien world. So cold that methane, which on Earth is a gas, becomes a liquid that can flow and pool and evaporate just as water does on our own planet. Imagine standing on the shore of a methane sea on Titan. The sky above is a hazy orange, the sun a faint, bright spot barely visible through the clouds. The liquid before you is not blue, but a dark, murky color, perhaps with a slight sheen of dissolved nitrogen. The ground beneath your feet is ice, but it feels like rock, frozen so solid that it will not melt for billions of years. There is something peaceful about Titan, despite its alienness. The thick atmosphere carries sound, so you could hear the waves lapping against the shore, if waves there were. The gravity is low, about 1/7 of Earth's, so you could walk easily, even bound in a heavy suit. And the cold, while profound, is not violent. It simply is, a constant presence that defines this strange and beautiful world. And then there is Enceladus. This small moon, barely 500 kilometers across, has captured the imagination of scientists and dreamers alike. Beneath its icy surface, warmed by the gentle flexing of Saturn's gravity, there exists a global ocean of liquid water. Geysers of ice and vapor erupt from cracks near its south pole, sending plumes of crystals hundreds of kilometers into space. These geysers are one of the most remarkable discoveries in the history of planetary exploration. They tell us that beneath the frozen surface of this tiny moon, there is warmth. There is liquid water. There are the conditions that might, just might, support life. But the surface of Enceladus remains locked in cold, minus 200 degrees Celsius and colder. A world of brilliant white ice, reflecting what little sunlight reaches this far from the inner solar system. A world of silence and stillness, where the only motion is the slow drift of ice particles falling back from the geysers, coating everything in a fine, frozen dust. The geysers of Enceladus feed one of Saturn's rings, a faint band of ice particles called the E-ring. Every second, hundreds of kilograms of ice spray out from the moon's south pole, only to be captured by Saturn's gravity and spread into a diffuse ring around the planet. Enceladus is slowly giving itself to the cosmos, one ice particle at a time. Let us drift further still. Beyond Saturn lies Uranus, the tilted world. This pale blue giant rolls through space on its side, its axis pointed almost directly at the sun. No one knows for certain why Uranus tilts so dramatically. Perhaps it was struck by an Earth-sized object billions of years ago, knocked over by a cosmic collision of unimaginable violence. Perhaps some other event, some gravitational interaction with a passing body, pushed it over in the early days of the solar system. Whatever the cause, this strange orientation means that Uranus experiences the most extreme seasons of any planet.
When one pole of Uranus points toward the sun, it experiences continuous daylight for decades at a time, while the other pole is plunged into equally lengthy darkness. Then, as the planet moves in its orbit, the seasons reverse. Uranus takes 84 Earth years to complete one orbit around the sun, so each of these extreme seasons lasts for more than 20 years. The temperature in the upper clouds of Uranus falls to minus 224 degrees Celsius. This makes it the coldest planetary atmosphere in our solar system, colder even than Neptune, which lies further from the sun. Something about the internal dynamics of Uranus, some quirk of its formation or structure, has left it with less internal heat than its distant neighbor.
Perhaps the same collision that knocked Uranus on its side also disrupted its interior, causing it to lose heat more quickly than it otherwise would. Or perhaps the planet simply formed with less internal energy to begin with. Whatever the reason, Uranus is a cold, quiet world, its pale blue face betraying little of what lies beneath. The moons of Uranus are dark and cold and quiet. Miranda, the innermost of the large moons, is a fractured world of cliffs and canyons, as if it was once shattered and then reassembled in a careless jumble. The cliffs of Miranda are some of the tallest in the solar system, dropping for kilometers into shadow-filled chasms. In the low gravity of this small moon, a rock dropped from the top of these cliffs would take more than 10 minutes to reach the bottom. Ariel and Umbriel and Titania and Oberon, these moons drift in patient orbits around their tilted parent, their surfaces scarred by craters and covered in frozen gases. Each one is a world unto itself, with its own history, its own geology, its own secrets. But they share one thing in common. They are cold, profoundly, deeply, eternally cold. Time moves slowly here, in the realm of Uranus. A single year on this distant world lasts 84 Earth years. A single day is just 17 hours long. The faint light of the sun takes nearly 3 hours to arrive, and when it does, it illuminates a world of pale blue clouds and frozen moons, drifting silently through the darkness. Let us continue our journey outward. Neptune awaits. This deep blue world is the most distant of the major planets, orbiting the Sun at a distance of 4.5 billion kilometers. At this vast remove, the Sun appears as little more than a bright point of light, a distant campfire glimpsed across an immense dark plain. You could block the Sun from view with a single grain of sand held at arm's length. That is how far we have traveled. That is how small the Sun has become. Neptune is a world of storms and wind. Despite its great distance from any source of warmth, this planet generates enough internal heat to drive the fastest winds in the solar system. Clouds of methane and hydrogen race across its face at speeds of over 2,000 kilometers per hour. Great dark spots appear and disappear in its atmosphere, storms large enough to swallow the Earth that form from nothing and dissolve back into nothing over the course of years. And yet, for all this fury, Neptune remains bitterly cold. The temperature in its upper atmosphere hovers around -214 degrees Celsius. The winds that howl across its face are not warm winds. They are rivers of frozen gas, racing through an atmosphere of ice and darkness. Triton, Neptune's largest moon, is one of the coldest solid bodies we have ever measured in our solar system. This strange world orbits backwards, moving against the direction of Neptune's rotation, suggesting that it was once a free-drifting object captured by the planet's gravity long ago. Triton probably came from the Kuiper Belt, that vast ring of icy objects beyond Neptune. It wandered too close to the blue giant and was captured, pulled into orbit by gravity's inexorable grip. Whatever moons Neptune had before were disrupted by this capture, thrown out into space or crashed into the planet itself. Only Triton remained, a prisoner circling its captor in endless retrograde motion. The surface temperature on Triton is -235 degrees Celsius. At this temperature, nitrogen freezes solid. The thin atmosphere of Triton, what little there is of it, falls like snow onto the frozen surface. Geysers of nitrogen gas erupt from beneath the ice, leaving dark streaks across the pale pink and white terrain. Imagine standing on the surface of Triton. The sky above is black, studded with stars that never twinkle because there is almost no atmosphere to disturb their light. Neptune hangs huge and blue on the horizon, but it offers no warmth, no comfort, only a faint reflected glow. The ground beneath your feet is frozen nitrogen, so cold that it barely reflects any heat at all.
In the distance, you might see one of the nitrogen geysers erupting, a plume of gas and dark particles rising kilometers into the thin air. This is not volcanism as we know it on Earth. It is not driven by molten rock. Instead, it is driven by the feeble warmth of the sun, which heats dark material beneath the transparent nitrogen ice, causing the gas beneath to expand and eventually break through to the surface. This is the cold of the outer solar system. Not the merely uncomfortable chill of a winter night, but a cold so deep that it changes the nature of matter itself. At these temperatures, gases become solids, liquids become impossible. Only ice remains in all its varied forms. Water ice, nitrogen ice, methane ice, carbon dioxide ice, each with its own properties, its own appearance, its own way of catching and scattering the faint light of the distant sun. And yet, even Triton is not the coldest place in our solar system. Beyond Neptune lies a vast and shadowy realm called the Kuiper Belt. This is a region of space populated by countless small, icy bodies, the frozen remnants of the solar system's formation. Here, where the sun's light has grown so faint that it barely illuminates anything at all, temperatures fall to minus 240 degrees Celsius and colder. Pluto drifts through the Kuiper Belt, that small, distant world that was once called the ninth planet. Its heart-shaped glacier of frozen nitrogen catches what little sunlight reaches this far, glowing a pale tan against the surrounding darkness. Its mountains are made of water ice, as hard as rock at these temperatures, rising kilometers above plains of frozen nitrogen and methane. Pluto's atmosphere, such as it is, freezes and falls to the ground as the dwarf planet moves further from the sun in its elliptical orbit. When Pluto is at its closest approach to the sun, this atmosphere expands slightly, a thin haze of nitrogen and methane that scatters the feeble sunlight. But as Pluto moves away, the atmosphere collapses, falling as snow onto the frozen surface, not to rise again for nearly 250 years. Beyond Pluto, there are thousands upon thousands of similar objects. Eris, nearly as large as Pluto, orbits in perpetual twilight so far from the sun that a single orbit takes more than 500 years. Makemake and Haumea and Sedna, these distant worldlets drift through the darkness, their surfaces frozen solid, their days and years measured in timescales that dwarf all of human history. And beyond even the Kuiper Belt, there is the Oort cloud. This theoretical sphere of icy objects surrounds our entire solar system, extending outward for nearly 2 light-years. The sun, from this distance, would appear as nothing special, just another star among millions. The cold here is almost indistinguishable from the cold of interstellar space itself. The objects in the Oort cloud have been drifting in darkness since the birth of the solar system. They have never felt the warmth of the sun. They have never experienced anything but the faint, ancient glow of the cosmic background radiation. They exist in a state of frozen suspension, waiting for some gravitational nudge to send them tumbling inward toward the light. Sometimes, one of these objects does fall toward the sun. Warmed for the first time in billions of years, its frozen gases begin to evaporate, forming a tail that streams behind it for millions of kilometers. We call these objects comets, and when they appear in our night sky, they remind us of just how much cold and darkness surrounds our small, warm world. But most of the objects in the Oort cloud will never make this journey. They will remain where they are, frozen and silent, drifting through the darkness at the very edge of the sun's gravitational reach. Billions of years from now, when the sun has burned itself out and the inner planets have long since been consumed, these icy worldlets will still be there, cold, patient, eternal. Let your mind drift now through this outer darkness. Feel the vast distances between the sun and these frozen worlds. Feel the patience of ice that has remained unchanged for longer than life has existed on Earth. There is no hurry here. There is no urgency. Only the slow, silent drift of matter through space and the endless cold that enfolds it. As we leave the outer reaches of our solar system, let us turn our attention now to the cold places that exist between the stars themselves. The interstellar medium, that vast and nearly empty space
where even the faint warmth of distant suns cannot reach.
We drift now beyond the boundaries of our own solar system, out into the great emptiness that lies between the stars. This is interstellar space, and it is a realm of profound and ancient solitude. The nearest star to our Sun, as we have mentioned, is over 4 light-years away. This distance is difficult for the human mind to grasp. If you could somehow travel at the speed of a commercial airplane, it would take you more than 5 million years to reach Proxima Centauri. Even light itself, the fastest thing in the universe, takes more than 4 years to cross this gulf. 4 years for light. Think about that for a moment. Light travels at 300,000 kilometers per second. In the time it takes you to read this sentence, light has traveled far enough to circle the Earth several times. And yet, even at this incredible speed, light takes more than 4 years to reach the nearest star. And in all that space, there is almost nothing. The interstellar medium is not quite a perfect vacuum, but it is very close. On average, there is roughly 1 atom per cubic centimeter in the space between stars. Compare this to the air you breathe, which contains something like 25 quintillion atoms in the same volume. The emptiness of interstellar space is almost beyond comprehension. If you could somehow magnify a cubic centimeter of interstellar space to the size of the Earth, each atom would still be kilometers apart from its nearest neighbor. That is how empty this space truly is. That is how alone each atom is, drifting through the void with almost no chance of ever encountering another. And because there is so little matter here, there is almost no warmth. The temperature of the interstellar medium hovers around 3 degrees above absolute zero, only slightly warmer than the cosmic background radiation that permeates all of space. This is the baseline cold of the universe, the temperature that space would naturally fall to if there were no stars, no galaxies, no sources of heat at all. Imagine drifting through this emptiness. There is no up or down here, no reference point at all except the distant stars, and they are so far away that they barely seem to move even over the course of years. The silence is complete. The darkness, when you look away from the stars, is absolute. You are alone in a way that is impossible to experience anywhere on Earth. And yet, even here, in this most empty of places, there is structure, there is form. There is, in its own slow and patient way, beauty. The interstellar medium is not uniform. It is filled with currents and eddies, like a vast, invisible ocean. Regions of slightly higher density drift through regions of lower density. Streams of gas, blown outward by ancient stellar explosions, curl and twist through the void. The magnetic field of the galaxy, impossibly faint but present nonetheless, shapes the movement of charged particles over distances of thousands of light-years. And scattered throughout this emptiness are clouds. Not clouds of water vapor, as we know them on Earth, but clouds of hydrogen and helium and tiny grains of cosmic dust. These are the interstellar clouds, the raw material from which new stars and planets will one day be born. Some of these clouds are vast beyond imagining. The Orion molecular cloud, visible from Earth as a faint smudge in the sword of the constellation Orion, is hundreds of light-years across. Within it, new stars are forming even now, their light slowly burning through the surrounding gas and dust. The Orion cloud is a stellar nursery, a place of creation and becoming, though on timescales so long that nothing seems to change from one human generation to the next. But other clouds are dark. They do not glow with the light of newborn stars. They absorb light, blocking the view of everything behind them. These are the dark nebulae, and they are among the coldest places in the entire universe. The dark nebulae are regions where gas and dust have accumulated to such density that starlight cannot penetrate. Within these cosmic shadows, temperatures fall well below the baseline of interstellar space, 10 degrees above absolute zero, 5 degrees. In the densest cores of these dark clouds,
Where the dust is thickest and the darkness most complete, temperatures can drop to just a few degrees above the ultimate cold. Let us drift into one of these dark clouds together. The first thing you would notice, if you could somehow make this journey, is the fading of the stars. As you enter the outer edges of the cloud, the brilliant points of light that filled the sky would begin to dim. The dust particles, each one smaller than a grain of sand, would scatter and absorb the starlight, filtering it like fog filtering the headlights of a distant car.
The transition is gradual. First, the fainter stars disappear, swallowed by the thickening dust. Then the brighter stars begin to dim, their light reddening as the blue wavelengths are scattered away. Finally, even the brightest stars are reduced to faint glows, struggling to penetrate the cosmic murk. Deeper into the cloud, the stars would fade entirely. You would find yourself in complete darkness, a blackness more absolute than anything that exists on Earth. There would be no light from any direction, no faint glow on the horizon, only the darkness, stretching in all directions, ancient and patient and cold. The temperature here would fall as the starlight faded. Without the gentle warmth of distant suns, the only heat would come from the cosmic background radiation, that faint echo of the universe's fiery birth. And in the densest parts of the cloud, even this ancient warmth would struggle to penetrate. But the darkness would not be empty. The dust that blocks the light also carries complex chemistry. On the surfaces of these tiny grains, atoms meet and combine in the cold and the dark. Water forms, molecule by molecule. Carbon dioxide crystallizes. Methane and ammonia accumulate in thin, frozen layers. In the cold darkness of the interstellar clouds, the building blocks of life slowly accumulate, waiting for the moment when gravity will draw them together into new stars and new planets. This is one of the great mysteries of the cosmos. The coldest, darkest places in the universe are also the places where new worlds are born. It is in the shadows that creation happens. It is in the silence that the universe prepares for new beginnings. The dust grains themselves are remarkable objects. Each one is a tiny seed around which molecules accumulate. They are made of silicon and carbon and oxygen, the ashes of stars that died long ago. They drift through the interstellar medium, collecting atoms on their surfaces, growing slowly larger over millions of years. When a dark cloud eventually collapses to form a new star, these dust grains are swept up into the process. They become part of the disk of material that surrounds the newborn star. They collide and stick together, growing from microscopic particles to pebbles to boulders to planetesimals. And eventually, over millions of years, they become planets. The Earth was built from such grains. The water in your body was once ice on the surface of interstellar dust, drifting through a dark cloud billions of years ago. The carbon in your cells was forged in the heart of a dying star, scattered into space, collected onto a dust grain, and eventually incorporated into the planet that would become your home. We are, quite literally, made of stardust, made of the cold, dark matter that drifts between the stars, made of atoms that have been on a journey lasting billions of years, from the hearts of ancient suns to the darkness of interstellar clouds, to the warmth of our own small world. And so the dark clouds drift through the galaxy, vast and patient, carrying their cargo of frozen molecules through the interstellar void. Some of them will remain dark for billions of years, undisturbed by any passing star or gravitational disturbance. Others will slowly contract under their own gravity, their cores growing denser and colder, until suddenly, in a flash of nuclear fire, a new star ignites at their heart. But that is a story for another time. For now, let us rest in the contemplation of this cosmic darkness. Feel the cold of it. Feel the stillness. In these dark clouds, time moves even more slowly than in the emptiness between. 1,000,000 years pass, and nothing seems to change. 1 billion years, and the cloud drifts on, patient and silent,
waiting for whatever comes next. There is a particular dark cloud that deserves our attention. It is called Barnard 68, and it lies approximately 500 light-years from Earth, in the direction of the constellation Ophiuchus. This cloud is relatively small, as interstellar clouds go, spanning only about half a light-year across. But within that modest span, it contains enough material to form perhaps 2 or 3 stars like our Sun. Barnard 68 is almost perfectly round, a dark sphere against the backdrop of distant stars. When astronomers photograph it, the cloud appears as a hole in the heavens, a place where no light escapes. It is one of the most studied dark clouds in the sky, precisely because of its simplicity. Its round shape and isolation make it an ideal laboratory for understanding how stars form. At its center, the temperature falls to just 6 degrees above absolute zero, cold enough to freeze nearly any gas into solid form, cold enough to slow the motion of atoms to a crawl, cold enough that the cloud is beginning to collapse under its own gravity, ever so slowly, preparing for the moment when a new star will be born.
And yet, Barnard 68 is not dead. Deep within its frozen heart, gravity is doing its slow work. The cloud is contracting, ever so gradually, its core growing denser with each passing millennium. In perhaps 100,000 years, perhaps 200,000, the core will grow dense enough and hot enough to ignite nuclear fusion. A new star will be born, and the darkness that has lasted for millions of years will be banished by its light. But for now, Barnard 68 drifts in silence through the interstellar medium. It has been there since before humans existed. It will remain there long after we are gone, unless some cosmic event disturbs its patient waiting. The cold within it is profound and ancient, a cold that has persisted since the early ages of our galaxy. Let us leave Barnard 68 now and drift further through the spaces between stars. As we travel, we might encounter the remnants of stars that have already died. The universe is filled with such remnants, the cooling embers of nuclear fires that burned for millions or billions of years before finally going out. When a star like our Sun reaches the end of its life, it swells into a red giant, casting off its outer layers into space. These layers drift outward, forming a beautiful shell of glowing gas called a planetary nebula. The name is misleading, as these objects have nothing to do with planets. They are the final breath of dying stars, the last exhalation before the stellar ember at the center begins its long, slow cooling. What remains after the outer layers have dispersed is a white dwarf, a dense core of carbon and oxygen no larger than the Earth, but containing nearly all the mass of the original star. White dwarfs are hot when they first form, glowing with a fierce white or blue light. But without any source of nuclear energy to sustain them, they slowly cool. Over billions of years, a white dwarf fades from white to yellow to orange to red. Its surface temperature falls from tens of thousands of degrees to mere thousands. The light it emits grows dimmer and dimmer, until eventually it becomes difficult to detect even with powerful telescopes. And eventually, given enough time, it will cool entirely, becoming a black dwarf, a frozen ball of carbon drifting through space, radiating no light at all. No black dwarfs exist yet. The universe is not old enough. Even the first white dwarfs, formed when the oldest stars died billions of years ago, are still faintly glowing. The time required for a white dwarf to cool completely is longer than the current age of the universe. But one day, trillions of years from now, the universe will be filled with these dark remnants. Cold, silent spheres drifting through an ever emptier cosmos. This is the fate that awaits all stars, even our own sun. In 5 billion years, give or take, our star will exhaust its hydrogen fuel and swell into a red giant. It will shed its outer layers, forming a beautiful planetary nebula that will glow for a few thousand years before fading away. And what remains will be a white dwarf, slowly cooling in the darkness, carrying the memory of the sun that once warmed our world. But there is no sadness in this thought, only peace. Only the recognition that all things have their time, and all things eventually return to stillness. The universe began in fire, and it will end in cold. This is simply the way of things, the natural rhythm of cosmic existence. Let your thoughts grow quiet now as we drift through the interstellar darkness. Feel the patience of the cosmos, the slow unfolding of time on scales that dwarf all human history. 1,000,000 years is nothing here. 1 billion years is merely an epoch. The stars will continue their slow dance long after every human who has ever lived has returned to stardust. And in the spaces between those stars, the cold remains, patient, quiet, eternal. As we drift further into the cosmic darkness, let us turn our attention now to a place of extraordinary cold, a place where temperatures fall below even the baseline of interstellar space, a place that holds the record for the coldest naturally occurring location we have ever discovered. In the southern constellation of Centaurus, approximately 5,000 light-years from Earth, there exists a dying star. This star, which has no common name but is cataloged simply as a central object within a planetary nebula, is in the final stages of its life. It is casting off its outer layers into space, creating a cloud of gas and dust that will one day fade away into the interstellar medium. This cloud is known as the Boomerang Nebula, a name given to it because early observations suggested it had a curved, boomerang-like shape. Later, more detailed images revealed that the nebula is actually shaped more like a bow tie, with 2 lobes of gas expanding outward in opposite directions from the dying star at its center. But the shape of the Boomerang Nebula is not what makes it remarkable. What makes it remarkable is its temperature. The Boomerang Nebula is the coldest natural place in the known universe. At the outer edges of this expanding cloud of gas, temperatures have been measured at just 1 degree above absolute zero, 1 degree Kelvin, colder than the cosmic microwave background, colder than the darkest interstellar clouds, colder than the surface of any moon or planet in our solar system or any other. Let that sink in for a moment. In all the vast reaches of the cosmos, in all the trillions of galaxies and quintillions of stars, this one small cloud of gas surrounding a dying star is the coldest place we have ever found. The universe has been cooling for nearly 14 billion years, and yet nowhere else has it achieved such profound cold. How can this be? How can a place so close to a star, even a dying star, be colder than the empty void between galaxies? The answer lies in a process called adiabatic cooling. When a gas expands rapidly, it cools. This is the same principle that makes the air feel cold when you release it from a compressed container, or that allows refrigerators and air conditioners to work. As the gas expands, its molecules spread out and slow down, and temperature is simply a measure of how fast molecules are moving. The dying star at the center of the Boomerang Nebula is shedding its outer layers at tremendous speed. Gas is streaming outward at over 160 kilometers per second, far faster than in most other planetary nebulae. This rapid expansion causes the gas to cool dramatically, falling below even the background temperature of the universe itself. In effect, the Boomerang Nebula is a natural refrigerator, cooling itself through its own expansion. The same process that will one day disperse the nebula into nothing is, for now, creating conditions of extraordinary cold. The star at the center of the Boomerang Nebula was once similar to our Sun,
though perhaps slightly more massive. It lived its life, burning hydrogen in its core for billions of years. It warmed planets, perhaps. It may have supported life somewhere in a solar system now long vanished. But eventually, like all stars, it began to die. As its hydrogen fuel ran low, the star swelled into a red giant, its outer layers expanding outward, growing cooler and redder. Then, in a final act of cosmic transformation, it began to shed those outer layers entirely, blowing them off into space at tremendous speed. This mass loss is not gentle. It is not the slow, patient drift of particles that characterizes most of the interstellar medium. It is a stellar wind of incredible power, stripping the star of its outer envelope in just a few thousand years. And as this wind expands into the vacuum of space, it cools with remarkable efficiency. Let us drift into the Boomerang Nebula together. Let us experience, in our imagination, what it might be like to visit the coldest place in the cosmos. As you approach, the first thing you would notice is the glow of the dying star at the center. This star is not like our Sun. It has passed through the red giant phase and is now contracting, growing hotter on its surface even as it runs out of fuel. It glows with a fierce white light, illuminating the expanding cloud of gas around it. The two lobes of the nebula stretch outward from this central star, vast wings of gas expanding into the interstellar darkness. In visible light, the nebula has a ghostly, ethereal appearance, the gas glowing faintly as it catches and scatters the light of the central star. But as you move away from the center, toward the outer edges of the nebula, the temperature would fall rapidly. The light of the central star would grow fainter, scattered and absorbed by the expanding gas. The warmth would drain away, replaced by a cold more profound than any you could experience elsewhere in the universe.
At the very edges of the nebula, where the temperature drops to just 1 degree above absolute zero, matter enters a strange state. Molecules move so slowly that they barely move at all. The very concept of temperature begins to break down as quantum effects become increasingly important. In this realm of ultimate cold, matter behaves differently than we are used to. Gases that would normally bounce and scatter begin to slow down, to settle, to become almost still. The random thermal motion that characterizes all matter at higher temperatures fades to almost nothing. It is as close to perfect stillness as the universe can achieve. And yet, even here, there is motion. The gas is still expanding, still flowing outward from the dying star. The cold is not static, but dynamic, a cold created by movement and change. In a few tens of thousands of years, the Boomerang Nebula will have dispersed entirely, its gas mixed into the interstellar medium, its extreme cold a fading memory. For now, though, it drifts through space, a bubble of extraordinary cold surrounding a dying star. Astronomers study it with radio telescopes, measuring the faint emissions of molecules like carbon monoxide that allow them to determine the temperature of the gas. And they wonder at this strange place, this natural refrigerator, this coldest of all known locations. There is something meditative about the Boomerang Nebula, something that invites contemplation. Here is a star at the end of its life, shedding the matter it has held for billions of years, creating in its dying breath the coldest place in the universe. There is no violence in this death, no explosion or catastrophe, only a slow, patient release, a gradual returning of borrowed matter to the cosmos. The central star will continue to contract after the nebula has dispersed. It will become a white dwarf, a dense ember of carbon and oxygen slowly cooling over billions of years. The gas it has shed will drift through interstellar space, eventually becoming part of new clouds, new stars, new worlds. One day, billions of years from now, the atoms that currently make up the Boomerang Nebula will be part of something new.
They will drift through space, perhaps for millions of years, before being swept up by a passing cloud. They will fall inward with that cloud as it collapses under its own gravity. They will become part of a new star, a new planet, perhaps even a new form of life. The cold of the Boomerang Nebula is not an ending, it is a transition. It is the pause between one story and the next, the silence between movements of a cosmic symphony that has been playing for nearly 14 billion years. Let your breathing slow as you contemplate this dying star. Let your thoughts grow quiet. In the coldest place in the universe, there is peace. There is stillness. There is the patient acceptance of change that characterizes all things in the cosmos. The Boomerang Nebula does not resist its fate. It does not rage against the cooling of its gas or the dispersal of its matter. It simply is, for this moment, exactly what it is. And in being exactly what it is, it has become something remarkable. The coldest place, the quietest place, a place of profound and perfect stillness. We can learn something from this dying star and its frozen breath. We can learn that endings are not to be feared. We can learn that cold and darkness are not hostile, but simply different states of being. We can learn that even in the most extreme conditions, there is beauty, there is wonder, there is something worth contemplating. The central star of the Boomerang Nebula will continue to cool over the coming millennia. It will become a white dwarf, then slowly fade toward the temperature of its surroundings. The nebula itself will disperse, its gases spreading ever thinner until they are indistinguishable from the interstellar medium. And the record for the coldest natural place in the universe will pass to somewhere else, some other corner of the cosmos that we have not yet discovered. But for now, the Boomerang Nebula holds its title. For now, it drifts through the darkness of the southern sky, a beacon of cold in a universe still warm with the light of stars. And we, from our small blue planet 5,000 light-years away, can contemplate its existence and wonder at the strangeness of the cosmos. There is comfort in knowing that such places exist. Comfort in understanding that the universe contains more than we can ever experience, more than we can ever fully understand. The Boomerang Nebula reminds us that the cosmos is vast and strange and full of surprises. It reminds us that even the cold can be beautiful. Let us rest here for a moment longer, in the contemplation of this extraordinary place. Feel the cold of it, even in imagination. Feel the silence. Feel the patience of matter returning to the void, ready to be born again as something new. And when you are ready, let us drift onward. Let us leave the Boomerang Nebula behind and venture further into the darkness, to explore other cold places, other silent realms. As we continue our journey through the cosmos, let us turn our attention now to the vast emptiness that exists between the galaxies themselves. For if interstellar space is empty, intergalactic space is emptier still. We have traveled far, from the frozen moons of our outer solar system, through the dark clouds of interstellar space, to the coldest known place in the universe. But our journey is not yet complete. There are colder places still, in a sense. Places where emptiness itself reaches its most profound expression. These are the cosmic voids, the vast bubbles of nearly empty space that exist between the great clusters of galaxies. To understand the voids, we must first understand the structure of the universe on the largest scales. When astronomers map the distribution of galaxies across the cosmos, they discover something remarkable. Galaxies are not scattered randomly through space. Instead, they are arranged in a vast cosmic web, clustering along filaments and sheets that stretch for hundreds of millions of light-years. Imagine, if you will, the foam in a bubble bath. The bubbles cluster together, their walls touching and merging, leaving empty spaces in between. The cosmic web is something like this, but on a scale almost beyond comprehension. The bubbles are voids, regions of nearly empty space. The walls are filaments and sheets of galaxies, millions upon millions of them, clustering together in vast structures that span significant fractions of the observable universe. And between these filaments, enclosed by these sheets of galaxies, are the voids. Regions of space where almost no galaxies exist at all. Bubbles of emptiness, some of them hundreds of millions of light-years across, containing perhaps a handful of dwarf galaxies where millions might be expected. The largest known void is called the Boötes void, after the constellation in which it appears from Earth. This bubble of emptiness is approximately 330 million light-years in diameter. To put that in perspective, our own Milky Way galaxy is about 100,000 light-years across. You could fit more than 3,000 Milky Way galaxies, laid end to end, across the diameter of the Boötes void. And yet, within this vast space, there are only about 60 known galaxies. 60 galaxies, scattered through a volume that could contain millions. The emptiness is almost perfect, almost complete. Imagine drifting through the Boötes void. Imagine leaving behind the crowded realms of the galactic filaments, where millions of galaxies blaze with the light of hundreds of billions of stars. Imagine moving deeper and deeper into the emptiness, watching as the galaxies grow fewer and fainter, until finally you find yourself alone in a darkness more complete than any we have yet contemplated. In the heart of the Boötes void, the nearest galaxy might be tens of millions of light-years away. The sky would not be filled with the familiar glow of the Milky Way, that river of stars that arches across our earthly nights. Instead, there would be only a few faint smudges of light, barely visible against the cosmic background. Galaxies so distant that their light has traveled for millions of years to reach you, and so faint that they barely register against the darkness. The temperature in the cosmic voids is essentially the same as the cosmic microwave background, approximately 2.7 degrees above absolute zero. There is so little matter here that temperature almost loses its meaning. A few atoms of hydrogen per cubic meter, drifting through emptiness that has remained undisturbed since the earliest ages of the universe. These voids have been empty for billions of years. When the universe was young, matter was distributed almost uniformly through space. But small variations in density, tiny fluctuations left over from the very first moments of existence, caused matter to begin clumping together. Gravity drew atoms toward atoms, gas toward gas. The dense regions grew denser, while the sparse regions grew sparser. Over billions of years, this process created the cosmic web we observe today. The filaments and clusters where galaxies congregate. And the voids, those vast empty bubbles, where almost nothing remains. There is something almost contemplative about the cosmic voids. They are places where the universe has, in a sense, returned to its original state of emptiness. Places where the chaos of matter and energy and light has not intruded. Places of perfect stillness, perfect quiet, perfect cold. If you were somehow able to exist within a cosmic void, you would experience a solitude beyond anything possible elsewhere in the universe. The nearest star, the nearest source of warmth and light, would be millions of light-years away. The cosmic microwave background, that faint glow left over from the universe's birth, would be the only radiation touching you. You would be utterly, completely, profoundly alone. And yet, even in this loneliness, there would be beauty. The faint smudges of distant galaxies, each one containing billions of stars, would remind you that matter exists, that complexity exists, that somewhere out there in the darkness, there is warmth and light and perhaps even life. The very emptiness of the void would make the existence of those distant lights seem all the more precious, all the more miraculous. Let us drift through this emptiness together. Let us feel the vastness of it, the silence of it. In the cosmic voids, time moves slowly. Nothing happens here. Nothing changes. A billion years pass, and the void remains essentially the same, its few scattered galaxies drifting imperceptibly through the darkness. This is the oldest cold in the universe. the cold that existed before the first stars ignited, the cold that will remain after the last stars have burned out. In the voids, we can glimpse what the universe will become, trillions upon trillions of years from now, when all the nuclear fires have faded and only darkness remains. But that future is unimaginably distant. For now, stars still burn, galaxies still glow, and we, on our small blue planet, can look up at the night sky and wonder at it all. There is another void worth contemplating, smaller than Boötes but closer to home. It is called the local void, and it lies just beyond the edge of our own galactic neighborhood. The Milky Way and its neighboring galaxies sit at the boundary of this emptiness, perched on the edge of a bubble of nothing that stretches for hundreds of millions of light years. When we look toward the local void from Earth, we see fewer galaxies than in other directions. The sky is darker there, emptier. It is as if our galactic neighborhood is situated on the shore of a vast cosmic ocean, looking out across waters where no islands appear. The local void is not as empty as the Boötes void. There are some galaxies scattered through it, lonely wanderers drifting through the darkness, but it is empty enough to be noticeable, empty enough to remind us that our position in the universe is not random. We exist at the intersection of cosmic filaments, surrounded by an abundance of galaxies on some sides and the great emptiness on others. Perhaps this is fitting. Perhaps it is appropriate that our view of the cosmos includes both the crowded brilliance of the galactic clusters and the silent emptiness of the voids. We are creatures of both light and dark, after all. We sleep and we wake. We seek out companionship, but we also need solitude. The universe, in its structure, reflects something of our own nature. The cosmic voids are not truly empty, of course. They contain dark matter, that mysterious substance that makes up most of the mass of the universe but neither emits nor absorbs light. They contain the cosmic microwave background, that ancient radiation that fills all of space. They contain, scattered here and there, atoms of hydrogen and helium, left over from the first moments of cosmic existence. But in terms of the matter we can see, the stars and galaxies that light up the night sky, the voids are as empty as any place in the universe. They are the closest thing to nothing that exists in our cosmos, the nearest approach to the primordial emptiness that preceded the birth of all things. Let your thoughts grow quiet now, as we rest in the contemplation of these vast, empty spaces. Feel the cold of the voids, that ancient cold that has existed since before the first stars. Feel the silence, that profound absence of sound that characterizes all of space but is most complete here, in the emptiness between galaxies. There is nothing to fear in this darkness. There is only peace, only stillness, only the patient waiting of space itself, holding open these bubbles of nothing against the slow encroachment of gravity. The voids will not last forever. Over billions of years, the filaments of galaxies will grow and spread, gradually filling in the empty spaces. The cosmic web will become denser, more complex. But then, as dark energy continues to push the universe apart, a different fate awaits. The expansion of space will accelerate, pulling galaxies away from each other faster than light can travel between them. The cosmic web will stretch and thin, and eventually, in the far, far distant future, the voids will win. All of space will become a void, empty and cold and dark. But that is a story for another time. Another contemplation. For now, the voids exist alongside the light. For now, they drift through the cosmos, vast and silent and cold. And we, from our small corner of one galaxy among billions, can wonder at their emptiness and find in it a strange kind of peace. As we drift back from the cosmic voids, let us turn our attention now to one final aspect of cosmic cold. Not a place exactly, but a time. The cold future that awaits the universe, trillions upon trillions of years from now. We have journeyed through the coldest places in space. We have visited frozen moons and dark nebulae, dying stars and cosmic voids. But there is one more realm of cold that deserves our contemplation.
It is not a place we can visit. It is a time we can only imagine. The future of the universe is cold. Today, the cosmos is filled with light. Hundreds of billions of galaxies, each containing hundreds of billions of stars, blaze across the observable universe. Our own sun warms our planet, supporting the incredible diversity of life that has evolved here over billions of years. It seems impossible that this light, this warmth, this energy could ever fade. But the universe is patient, and the laws of physics are inexorable. Stars shine because they are converting hydrogen into helium in their cores, releasing energy through nuclear fusion. But hydrogen is a finite resource. Every star in the universe is slowly using up its fuel, burning through the matter that sustains it. Our own sun has enough hydrogen to continue shining for another 5 billion years, give or take. But that is merely a moment in cosmic time. As the eons pass, the rate of star formation will slow. The great clouds of gas and dust that give birth to new stars will gradually be used up, converted into stars that burn for a while and then die. Fewer and fewer new stars will ignite. The universe will grow dimmer, not suddenly, but gradually, over timescales that dwarf all of human history. 1 trillion years from now, star formation will have essentially ceased. The galaxies will be filled with the cooling remnants of dead stars, white dwarfs, slowly fading toward invisibility, neutron stars spinning ever more slowly as they lose energy to the cosmos, black holes, dark and silent, growing imperceptibly as they consume the occasional piece of debris that falls within their grasp. 10 trillion years from now, the last red dwarf stars will flicker and die. These small, dim stars burn their fuel so slowly that they can shine for trillions of years, far longer than our own sun. They are patient stars, conserving their energy, glowing with a faint red light that barely illuminates the worlds around them. But even they are not eternal. Eventually, the last nuclear fire will go out, and the universe will be plunged into darkness. This era is called the Black Dwarf Era, or sometimes the Dark Era. It is a time when no new light will be generated by nuclear fusion. The only light will come from the slow decay of matter itself, and from the occasional collision of objects in the darkness. The universe will be cold, silent, and nearly empty of anything that we would recognize as activity. And yet, even this is not the end. Over timescales so long that they cannot meaningfully be expressed in years, the black holes themselves will evaporate. Through a process called Hawking radiation, black holes slowly lose mass, emitting faint streams of particles that carry away energy. Small black holes evaporate relatively quickly, in cosmic terms, but the supermassive black holes at the centers of galaxies will take an almost incomprehensible amount of time to fade away. When the last black hole evaporates, the universe will be left with only scattered particles, drifting through an emptiness that stretches beyond imagination. The temperature will be just barely above absolute zero, and it will continue to fall, asymptotically approaching that ultimate cold as the universe continues to expand. This is the heat death of the universe. Not a violent end, but a gradual fading. Not an explosion, but a whisper. The cosmos will grow cold and dark and empty, and it will remain that way, as far as we can tell, forever. There is something peaceful in this vision of the future, something that invites acceptance rather than fear. The universe will not end in catastrophe, it will simply rest. After trillions upon trillions of years of activity, of star formation and supernovae, and the endless dance of matter and energy, the cosmos will finally grow still. And perhaps in that stillness, there will be a kind of completion. The universe will have expressed everything it had to express, created everything it had to create. The story will be finished. Not with a dramatic conclusion, but with a gentle fade to silence. We cannot know, of course, what might exist in that far future. Perhaps there are forms of existence that can persist even in a universe of almost perfect cold. Perhaps intelligence will find ways to survive,
to extract meaning from the tiny fluctuations of energy that remain. Or perhaps the future is simply rest, peaceful and eternal, the cosmic equivalent of a long and dreamless sleep.
What we do know is that the cold is coming. Not soon, not by any measure that means anything to human life, but eventually, inevitably, the universe will cool, the stars will fade, the darkness will deepen, and the cold that already fills most of space will spread to encompass all of it. Let this thought settle gently into your mind, not as a cause for sorrow, but as an invitation to perspective. The warmth we know, the light we see, these are temporary gifts. They are precious precisely because they will not last forever. The universe has given us this moment, this brief era of stars and warmth and life, and we can appreciate it all the more knowing that it is fleeting. For now, the stars still shine. For now, the sun still warms our world. For now, we are here, alive and aware, contemplating the cold places of space from the comfort of our own small warmth. And that is enough. That is more than enough. That is miraculous. Let your breathing slow. Let your body grow heavy with approaching rest. The cold future is unimaginably distant. Tonight, you are warm. Tonight, you are safe. Tonight, the universe holds you gently in its vast embrace. And so we begin our return. Let us drift back from the contemplation of cosmic futures, back through the voids between galaxies, back past the dying stars and dark nebulae, back to the familiar warmth of our own solar system, our own planet, our own small place in the cosmos. We have traveled far tonight. We have visited the coldest places in space, from the frozen moons of our outer solar system to the vast emptiness of the cosmic voids. We have contemplated temperatures that drop below even the background chill of the universe itself. We have glimpsed the cold future that awaits the cosmos trillions of years from now. And now, we return. As we drift back through the darkness, the familiar lights of home begin to appear. The Milky Way stretches across the sky, that river of 400 billion stars that we call our galaxy. The sun grows brighter, no longer a distant point of light, but a warm, golden presence at the center of our solar system. The blue-green sphere of Earth comes into view, that precious oasis of warmth and life in the cold vastness of space. Home. We are made of the same matter as the stars, you and I. The atoms in our bodies were forged in the hearts of ancient suns, scattered across space by supernovae, gathered together again into new stars and planets, and eventually, into us. We are the universe contemplating itself, the cosmos grown aware of its own vastness and cold and beauty. And we are warm. Against all odds, in a universe that is mostly darkness and emptiness and cold, we exist in a place of warmth. Our sun burns steadily, providing the energy that powers all life on Earth. Our atmosphere holds that warmth close, wrapping our planet in a blanket of air that keeps the cosmic cold at bay. This is the gift we have been given. This brief moment of warmth in an ocean of cold. This precious era of stars and light before the long darkness comes. We can spend our time in gratitude for this gift, in wonder at the strangeness and beauty of the cosmos that produced us. The cold places of space will still be there tomorrow. The Boomerang Nebula will continue its patient expansion. The cosmic voids will drift on, silent and empty. The frozen moons of the outer planets will turn slowly in the faint light of the distant sun. They have been there for billions of years. They will be there for billions more. But tonight, you are here, warm and safe and resting. The universe holds you gently, as it holds all things. The stars shine down through the darkness, sending their ancient light across the void to reach your eyes. You are part of this vast story,
this cosmic drama that has been unfolding for nearly 14 billion years. And what a story it is. From the first moments of existence, when all of space was compressed into a point smaller than an atom, to the vast expansion that created the cosmos we know today. From the birth of the first stars to the slow cooling of the universe. From the formation of galaxies to the emergence of life on at least one small world, circling an ordinary star, in an ordinary galaxy, in a universe of extraordinary scale and beauty. You are part of this story. The atoms in your body have been on a journey lasting billions of years. They were forged in the hearts of stars. They drifted through the cold of interstellar space. They fell together to form the Earth, and eventually, through processes we are only beginning to understand, they came together to form you. You are stardust, contemplating the stars. You are the universe, become aware of itself. And tonight, you can rest in that knowledge, knowing that you belong to something vast and ancient and beautiful. Let your eyes close now. Let your thoughts grow still. The journey is complete, and it is time to rest. In the spaces between stars, the cold waits patiently. In the hearts of dark nebulae, new worlds are slowly forming. In the cosmic voids, emptiness stretches on forever. And here, on this small blue planet, circling an ordinary star in an ordinary galaxy, you are drifting towards sleep.
The universe is vast and silent and cold. But you are warm. You are home. You are at peace. Think for a moment of all the cold places we have visited tonight. The frozen moons of Jupiter and Saturn, locked in ice for billions of years. The distant reaches of the Kuiper Belt, where Pluto and its companions drift through perpetual twilight. The dark nebulae, where temperatures fall to just a few degrees above absolute zero and new stars wait to be born. Think of the Boomerang Nebula, that coldest of all places, where a dying star creates conditions colder than anywhere else in the known universe. Think of the cosmic voids, those vast bubbles of emptiness where almost nothing has stirred since the beginning of time. All of these places exist, right now, as you rest here in your warmth. They are out there, in the darkness, patient and silent and cold. And they will remain there, unchanged, while you sleep and dream and wake again to another day. There is comfort in that constancy. Comfort in knowing that the universe continues its slow dance, whether we are watching or not. The stars do not need our attention to shine. The cold does not need our acknowledgement to persist. The cosmos simply is, vast and ancient and beautiful, and we are privileged to be a part of it for this brief moment in time. So rest now. Let the weight of your body sink into stillness. Let your breathing slow to match the patient rhythm of the cosmos. You have traveled far tonight, through cold and darkness, through places of profound silence and ancient stillness. Now it is time to return to the warmth of your own small world, your own small life, your own small moment in the vast sweep of cosmic time. The cold places of space will wait for you. They have been waiting for billions of years. They will wait a little longer still. And so, we rest among the stars, safe in our warmth, held by the gentle gravity of our small world, connected through the atoms in our bodies and the light in our eyes to everything that has ever been and everything that will ever be. The universe whispers its secrets to those patient enough to listen. Tonight, it has whispered of cold and darkness, of vast emptiness and profound stillness. And in that whisper, perhaps, we have heard something of ourselves, our place in the cosmos, our connection to all things, our belonging to something far larger than we can ever fully comprehend. Sleep now. Dream of stars and silence. Dream of cold places and ancient light. And know that when you wake, the universe will still be there, waiting to share more of its wonders with those who take the time to look. Good night. And so,
we rest among the stars.